Hey everyone, and welcome to the channel. This is going to be part 2 in creating a deepfake. In the first video, check that out if you haven't already seen it. It's going to cover all the prerequisites as far as hardware and software and installation that you need in order to get going. So please check that out first if you haven't already. So let's go ahead and dig in. Alright, so if you haven't already, the first thing you're going to want to do is going to extract the DeepFaceLab executable that you hopefully already got in the previous step. And once you extract that, you're going to have a folder that you can go ahead and go inside of. And it's going to have a bunch of batch files that you're not going to need to use all these. I'm going to go over these bit by bit. But inside the workspace folder, if you double click, there's a data source and data DST file here. And a few of these are just example files of some Elon Musk and then Robert Downey Jr. footage where they were using this as a face swap. And so go ahead and take these guys. I'm going to make a new folder and just call this examples and drag these in here. I'm not going to need these, but just in case, sometimes it's nice to be able to reference those. So what you're going to want to bring in here now is you're going to want to have edited versions of the footage you want. So what you're actually trying to go to, where you want to put the footage on top of, which is your destination, then your source footage on who you want to be the replacement actor. And this has already been edited in an editor like DaVinci Resolve or Premiere. You're going to want to have just the footage you want, so no one else's face, or if there's scenes from the film that have both, that's perfectly fine. We'll get into how you can filter out other faces like Elizabeth Shue's character in other scenes. I'm going to go ahead and drag these guys in here so I can have these to work with. And once it's done copied, we'll go and pick up from there. So once we have our data destination and data source files, I'm going to go in and go up one folder from the workspace folder to the DeepFaceLab main folder with all the batch files. And the first one I'm going to do is extract images from video data source. If I go in and double click on this guy, it's going to ask me how many frames per second do you want this to be. If you press question mark and press enter, you're going to get a description of each step, and this is going to be useful in the other batch files. But saying how many frames of every second of video is going to be extracted. And this is going to vary based on what type of footage and how much of it you have. If I go ahead and open this up and drag it over here, you can see that the source footage of Jason Momoa is 16 minutes and 20 seconds long. Now, we don't want to use every single frame of this because it's probably going to be too repetitive. And basically, the idea is you want to feed it enough frames where it's able to learn person's face, learn all the different angles and all the different expressions they make, but you don't want to feed it too much because then it's going to take too long to train and learn all those faces. You're going to get different opinions on how many you need. We've been shooting for about 6,000 images of the face. That tends to cover a pretty good amount. And how you want to tackle this is completely up to you, but I believe I had about 16 minutes and 20 seconds, and in here I just have an Excel sheet. But it basically breaks down into total seconds of footage that we have. And this is just calculating the difference, trying to get the target frames per second of what we need to get around 6,000 frames total. And in this case, I'm getting around just about 6 frames per second as my target. Again, I can break down the math if you guys want, but I'm going to go ahead and just go over here into this batch file. I'm going to go ahead and type in 6 for the frames per second. I'm going to go and let this guy start computing, and I'm going to go and use JPEG files. There's really no need for the PNGs, especially if you're going to be posting this online. The slight loss in quality and training quality, it's probably not going to be worth it, but you can certainly go with PNGs if you want. I'm going to go and let this extract all the frames. This does take a while, but once this finishes, it'll say press any key to continue, done. We'll go ahead and press spacebar, and then we're going to actually go ahead and do the exact same thing for the data destination. But with the data destination, we'll go ahead, scroll down. So the first one we used was extract images from data source. If we go ahead and down to data destination, you can see it defaults to full frames per second because we actually want to put the replacement face on every single frame of the scene. So we'll go ahead and extract every single frame from our destination footage. And again, I'm going to go and use JPEGs, and we'll go and let this finish as well, and we'll pick up once this is done. So once both of those finish, what you should have is you go under the data DST folder, you're going to see extracted image sequence of all of the source footage or what you're wanting to put the new faces onto. If we go into the data source folder, we're going to see all the footage, in this case of Jason Momoa, who we want to replace the Deep's actor with. So that's the first step that we need to go through. And again, the nice part about all these batch files is you just follow through the numbers, use the ones you need, and work your way down to the end. But you don't need to use, by any means, all of these. So now that we've extracted both the data source and data DST, the next thing we need to do is try and extract the faces. Because remember, right now, we have full images right here. And actually all we're really interested in is just the small area of the actor or actress's face. So I'm going to go ahead and inside the main folder, the next step is going to be extracting the face set. So we'll go ahead and do data source face set extract, take out just the faces from the full images. And this is where things are going to get slightly different. You might have to figure out what your particular graphics cards will do. Is in some of these steps, not necessarily this one, but in some steps, the amount of VRAM you have on the card. All my cards here have 8 GB of VRAM. If I go ahead and if you do have multiple graphics cards, it would actually go faster if you use multiple ones. You can just separate them with commas. But I'm going to go in and select this, and it's going to ask me a few different questions. And if you're ever not sure what it is, you can do question mark and enter. It's going to give you a description. For most of these we've done on as art, check out those deepfakes if you want to see those. We've done whole face, so I'll go ahead and press enter and choose the default. And the max number of faces from each image, that's saying, okay, if I'm looking at a particular image in the image sequence and I detect 5 or 6 different faces on there, how many do you actually want me to actually be allowed to use? A good number is about 3. You can use more or less. And again, the image size might vary based on what you're using. In this case, 512 tends to be a pretty good amount, but it says you can use higher than 512 only if the source image is sharp enough and the face does not need to be enhanced. So I'm thinking probably 512 is good. I'll go ahead and press enter, and our JPEG quality, it defaults JPEGs in this step. I'm going to go ahead and just press enter to keep that the same. And our write debug images to align debug is an image sequence. So it's basically going to make 2 image sequences. It's going to make one of just the face, and it's going to do another one with basically a grid or the wireframe of it trying to detect the face. And that helps you troubleshoot if there's any discrepancy or you're not sure if it detected the face correctly. I like to do this because it's fun to be able to look at and use in breakdowns when you post it to YouTube, but you obviously don't have to do that. So I'm going to go ahead and do yes. And now it's going to go ahead and load the images and extract them using the GPUs that you specified. So this does take a little bit to get up and going. More or less, you just kind of let it do its thing. And once it's done, you're set to go to the next step. Once that step finishes, we're going to go ahead and just double check. We'll go inside our data source folder. And you're going to see that along with all the base image sequences that we had, we also have an align folder, which is just the faces. And it's kind of funny because, and when you look at them, you can kind of see that the face is kept dead center, which is what it needs. And the other folder that we have is the align debug folder. And this is where we have the face with the grid on top of it to show how well it has stuck to the face itself. Once we've confirmed that it's worked fine, we're going to go back to the actual main folder. And instead of doing source face set extract, we're just going to work down the line and we're going to do the data destination face set extract. Now here you have a couple different options. You can do the completely automated version like we did up here with just face set extract. Or if you want to be able to do face set extract plus manual fix, this is saying that, okay, if it doesn't do a great job or it can't find or perfectly detect the face in a particular frame, it's going to ask you to fix it after the fact. I'm going to go and do the automated version, but if you're finding you're not getting the faces extracted successfully, you might want to go back and do the manual fixes. So go and double click on this guy. This is going to be the exact same as last time. And I actually, if you're using your main graphics card, you want to close out any other programs that the graphics card might be giving resources to, because actually when I pulled it with all 3 graphics cards last time, it gave me an out of memory error on the 2080. In this case, since I'm going to keep using that card while it's processing, I'm just going to use the 1080s. But if you're using one main graphics card, make sure that you close down other things that might be using the graphics card in the background. So definitely would want to be video editing or something like that during the same period of time. Now, if you are a statistic nerd like I am, you might want to see what's actually going on in the actual processing. And looking at Task Manager, and I drop down the 2 GPUs that are being used here, we can go ahead and take a look, not under video encode, but actually under CUDA. This is where the processing, and why you have to have an NVIDIA graphics card, this is where the processing is being done. So you can see that it's actually not using the entire graphics card, but it is using a good amount of CUDA cores. So it's using about 46%. And about 45% here. So that's kind of giving you a better idea on what's actually going on. So now that we've extracted the faces from both sets, we're going to go ahead and actually sort them so we can take out the faces that aren't actually the actors that we want to replace or use as the source footage. So I'm going to go ahead and under both of these, we're going to work our way down the line here. For data source, we're going to choose sort. And you have a bunch of different sort options here, but the one that seems to work well is histogram similarity. So this is going to pair and put next to each other the faces or the images that look similar. And so if you happen to have other actors or actresses that are detected and faces are detected, it's going to clump those together that it thinks are similar as far as similarity and help you filter them out or keep them a lot more quickly. The amount of time it's going to take is going to be very much based on how fast. I think this is more CPU based, so if your CPU is a little bit faster, this might go quicker, but overall compared to the actual extractions and things like that, they should go pretty quickly. So the sorting is completed. I'm going to go and press any key to continue. And I'm going to just go ahead and in this video do the data source sorting because it's going to be the exact same step for the data destination, but there's no need to really repeat that twice. But now that it's sorted them, I'm going to go ahead and view the aligned results, which is one step up from that. If I double click on this, it's going to open a little viewing program here. If I make this as big as I can, and by the way, the higher the resolution, the more photos you're going to be able to see on screen at once. But basically what you want to do is you just want to scroll through and say he was moving his arm right here or his hand and it went in front of his face. You'd want to delete those images. It's not actually deleting the images from the main folder. This would be taking the images, deleting the images out of the aligned folder. So these are the only images that are going to be used in the training to replace the destination face. And so, but it's not going to delete these full frame images. So you always have these and it's just going to affect these aligned results. So as I scroll through here, I'm just going to be looking where if his face is very blurry, it's moving very fast, I'm going to want to take those out, or if his hand crosses in front of his face, or it detects the wrong person. So in this case, you can see it's grouped these frames together where the hand went in front of the face. I'm just going to delete these. And for the part where it has the motion graphics in front, I'm probably going to go ahead and delete these as well. It looks like we're getting enough. Probably we're going to have enough where we don't need these. I don't want this lit up part in the bottom of the graphic kind of messing with his face here. This is not close enough to where it's hitting his face, so I can probably keep those. I'm just going to go through here and start to filter these around. And since we've done the sorting, if there's big issues, it's probably going to make it a lot easier to see. And obviously take your time on this. I don't want to take too long in the video, but okay, so here it's kind of hitting his chin a little bit. Here, I think that's probably, but just in case, I'm going to go and delete these guys. Obviously, I don't want these ones. This is really blurry here, so I'll go and delete this guy. And you can imagine this can take a little bit, but it's very much worth trying to get these good to begin with. We do tend to feed a little bit more images to the trainer than usual. This is because it's going to basically average all these frames. If it finds multiple frames from the same angle and the same motion and things like that, it's going to average them together so you get a decent result even if not every single image is perfect. And again, we try to find different interviews, try and find different sources and things like that. If he looks way different from role to role, you want to try and choose images that are close to the role he's going to be doing. Let's see, so here I'll go and delete the image here. This is a little bit blurry, so I'll delete this one. The hands in front of the face, or hands to the sides, aren't really affecting the face there, so I think that's probably fine. And again, I won't take too long here, but you guys are probably getting the general idea. And you just work your way all the way down, and I won't do all this here on camera, but you're going to find particular frames that are way messed up. It finds pictures in the background or photos that don't correlate at all, that are upside down, and obviously you want to delete those ones. Those are ones you mainly want to make sure that you don't have. So I'll just kind of, not rush through here, but I'll go a little bit faster. And again, I'll grab these guys that are pretty motion blurred here. And just for the sake of being able to show you some examples, again, I'm going through these much more quickly than I would typically. Partially, if his face is getting too close to the edge of the screen, you'd want to take those off as well. I don't think any of these are too close where it's going over the part of the face that we want. And you can see it's sorted a number of images that are clearly not the face here. So we don't want his hair to be a face. We'll go ahead and delete these guys straight away. Don't worry about those. It's kind of put some blurry images together as well. Go and delete these. And then of course we have some that is the interview and not actually him at all. We'll go ahead and delete those as well. So if you get a number of faces that were in the same scene or things like that, you'll definitely want to delete those if it's not the actual actor that you're wanting to try and keep. And once you're done, you go ahead and close that down. Then you're going to go ahead and do the exact same process for your data destination. So you're going to be doing your data destination sort and then your data destination view aligned results and go through the exact same process. So with your source and destination images cropped and filtered, you can go ahead and get in the process of actually do the training, which is what you think of when you think of a deepfake. And you do have different algorithms you can use. These are always developing, so you might see different versions that come into play as time goes on and the deepfake software is developing. The one that we typically use is the SEEHD. So I'm going to go ahead and double click on here to start the train SEEHD option. I'm going to go ahead and give the file name, so I'll call this the DeepMoa. and I'm going to tell it which graphics card to use. And so in these following steps, it's going to be either higher or lower or different based on the graphics card you have. All my cards, again, are 8GB cards, and based on the amount of VRAM, you can up those settings or lower those settings. I'm going to go ahead and put up on screen here the settings that I tend to use, but remember, this is only if you have an 8GB card. If you have more, you can use the same settings, but you can probably put them higher. So I'm going to go ahead and tell it to use one of the 1080s here. And I'm going to have it auto backup probably about every 5 hours. You don't have to back up at all, but just in case it gets corrupted, especially because this could take days to do, you probably want to have it backing up somewhere along the line. And preview history, it's basically going to give you a time lapse of the development. This can help you figure out if you've given it enough time to get as much detail as you can, or if you want to give it more time to try and develop further. Now, the choose image for preview history is going to let you choose the image it's going to use for that image sequence, so you can choose something that has the extremes of acting or things like that to help you figure out how far it's progressed. Target iteration is going to vary a lot based on what you're trying to do. I'm putting 350,000 here. I might not let it go that high. You can see in these previous settings, I had it at 450,000, so it's really just going to depend. Let's go ahead and go on through here. Flip faces randomly. This is on by default. You're probably going to want this on. And basically, this is going to flip the faces from the left side to the right side to try and fill in the gaps, especially when it comes to the side views of the face or profiles. It tends to not have as many images, or when it's looking up and down. So if it's allowed to flip the faces, since our faces are asymmetrical, they're not perfect, but they tend to be close enough, it can fill in some of those gaps so you get better results. So I'll go ahead and let it flip randomly. The batch size is going to be very much based on your resolution and the amount of VRAM you have. So since I run it at a high resolution, I have to run this a little bit lower, down at a value of about 3, like I have here. That's tends to be quite low, but since we're trying to get higher quality or larger images at the end of the day, we tend to still go with that. Now, the resolution is probably one of the biggest things, because this is going to be how big the images it's outputting are after it's done processing. So if you have a teeny tiny image, no matter how much time you give it to process, when you try and put that on top of an image sequence, this 1920 by 1080, if it's squeezing it up from 64 by 64 pixels, it's going to be very blurry. Whereas the bigger you allow it to be, it's going to take longer to process, it's going to take more VRAM, but you can get more detail in there. So we've been able to settle with, again, just with 8GB cards, a batch size of 3 and a resolution of 256. But again, that's going to vary based on what you're doing. Now, face type, we just usually leave this on full, but you can do different sizes or amounts of the face. And so you can go and use the question mark and decide what you actually want to do here. I'm just leaving it on default. And the architecture is, again, how it's going to go about these things. And we tend to do, just in this case, we're going to go and leave it on deepfake. In the autoencoder dimensions, we're going to leave these roughly the same. Leave these guys as is. Eyes priority, we're going to run later on after we do the initial training. So we'll leave that off for now. Uniform, we'll leave that off for now as well. Place models and optimize our GPU. This is the big one where this is going to go much, much faster. It's basically going to load everything it needs onto the graphics card, video RAM itself. But the downside is you have to really optimize it to fit on there. So if you, in any of these steps, if you choose numbers or values that are too high, you're going to get an out of memory error. That just means you need to go back and adjust these settings until you can fit everything on the graphics card and its capabilities. So I'm going to go ahead and put this on the optimizer, which is a big thing that makes things go way faster. Use linear rate dropout, we'll leave that off for now. Random warp of samples, we definitely want to have on for now. GAN we'll use later on. And we'll go ahead and go down to the last couple options here. So you always want to have enable gradient clipping on. This is off by default, but this basically stops the process from breaking down and losing all your work. It goes a little bit slower when you have that on, but you should probably always have it on. And pre-training is something I'll maybe talk about in the very last video of the series, but this is something that can help you get ahead from the get-go, but you train it with generic faces at first. So I'm going to leave this off for now. And now that's the last option, is to go ahead and start loading all the images onto the VRAM of the card, and it's going to go ahead and start doing our deepfake process. And at first, since we did the preview history, it's going to ask us what image we actually want to use as our time lapse. All right, so it's loaded the images onto the card, and now it's popping up saying which image, in this case, since I chose that option, which image do you want to do the time lapse for? And in this screen, I can go ahead and press P for next or enter to confirm. I'm going to go ahead and choose some images that have kind of the extremes of acting if I can find them together. And this seems like a good image because we have Jason Momoa looking at camera, looking down, which tends to be a harder image to train because you don't see them looking down or up or down or left or right things as much. And we have some good expressions on this guy as well, the Deep from The Boys. So I feel like this is a good image. And when I show you the progress, the time lapse, this is going to be from an already pre-trained version. So it's not going to be the exact same images, but it gives you the general idea. So now that I know which one I want, I'm going to press enter to confirm. It's going to try and load that first sample onto the graphics card. If it says out of memory, just remember that you need to go back and just adjust your settings until it works okay. And if you get this guy popping up and it's starting to do the iterations like we can see it's doing here, then your deepfake has launched as it's starting successfully. Again, the one thing you want to watch for, if you see an out of memory error on here, you need to make sure and go back, just exit out of this. You can press escape or enter to exit, and you need to go back and adjust your settings. So now this is going. If I go ahead and press P to update, it's going to show me different frames, but I can see here that it has a very, very rough idea of what the face is looking like, but this is going to start training the faces both for your destination and your source. Now that this is running, this is what's going to take a very long time. You might have to wait days, or it just really depends on the settings and the capabilities of your graphics card. But now you successfully kicked off and prepped and have a deepfake running on your home PC. If you want to save at any point, press enter. It will go and save your process, and you can exit out, and that way you can go ahead and use the computer if you need to and start up again later on. And once you start your initial deepfake, all you need to do is go back and do your train SAE HD, and you can choose a different graphics card if you want to, but you go and choose the graphics card you want to use, and it's going to say if you want to change anything, press a key to override, but in this case I wanted to keep the exact same settings, and it's going to start loading up and just pick up where it left off. All right, so now we've gone through the process of prepping all your images, aligning them, and filtering them, and starting the training. We're going to go ahead and stop this video here. In the next video, we're going to talk about what you do once your training is complete. How do you know when it's done? What are the last settings you might do to get more quality out of it? And then how do you go through the important process of rendering out your deepfake and compositing it so it looks as absolutely good as it can. Hopefully this has been really helpful and insightful, and I'll see you on the next Johnny How To.